Take a look at this set of images. What is your first impression? What model generated this set of images? I believe many of you might say that they were generated by Nano Banana 2. The reason is that the images I am showing look very similar to some of the creative concepts we used when testing Nano Banana 2. These include the stylized image generation you are familiar with, more complex text and image layout generation, highly textured photorealistic image generation, storyboard and split screen images, character design, and even some advertising creative designs and city card designs that you guys are quite interested in. But I can tell you that these were not generated by Nano Banana 2. Furthermore, they were generated by an open source image generation model. The generation capabilities and prompt adherence of this model are probably the best among current open source models. The model we are going to focus on today is Ernie Image. Ernie Image is an open source image generation model launched by Baidu. So what are the core advantages of this model? First is the combination of small parameter size and high performance. This model only has 8 billion parameters and can run on consumer-grade graphics cards. However, the quality of the images it generates can rival commercial models like Nano Banana 2. Additionally, it features powerful text rendering and instruction following capabilities, as well as structural image generation capabilities. By structural images, we mean things like posters, PowerPoint slides, storyboard images, or complex text, and image layouts. It can render all of these exceptionally well. Moreover, this model has a built-in prompt enhancer. This is mainly to solve the issue where users write prompts that are too simple, resulting in lower quality generated images. This prompt enhancer is also very small in size, with only 3 billion parameters. I also suggest you guys pay attention to Ernie Image's ranking on the leaderboards. On its blog page, you can see various benchmark leaderboards. You will notice that Ernie Image's ranking is lower than commercial models like Nano Banana 2, but it ranks higher than almost all of our current open source models, including QWimage and ZImage. Also, on this leaderboard, we can see that Ernie Image actually has two models. One is the standard model we normally use, and the other is a turbo model. You will also notice some special markers. For example, we often see P and sometimes Baidu. What does this mean? First, P stands for prompt enhancer. Whether it has DUIO or not just indicates whether the prompt enhancer is turned off or on. Therefore, you will see various Ernie models appearing on this leaderboard. Just knowing the difference between them is enough. Currently, official ComfyUI already supports this model. You can open the ComfyUI blog, where there is an article specifically introducing how to run the Ernie Image model in ComfyUI. You can also download the corresponding models from the official ComfyUI Hugging Face repository. For the main model, we can see there are two. One is the turbo model, and the other is the standard transformer model. You can also download the corresponding text encoders and the VAE. Among the text encoders, one is the prompt enhancer we just mentioned. Actually, if you look closely, this text encoder and our VAE are identical to the ones used in Flux 2. So, if you have already downloaded them before, there is no need to download them again. At the same time, this blog post also provides a download link for the workflow. Besides downloading the workflow from the blog, you can also download it from our ComfyUI templates. First, you need to update your ComfyUI to the latest version. Click the template button and in the model selection box, choose Ernie Image. At this point, you will see two workflows, one based on the standard Ernie Image model and the other based on the turbo model. To make the demonstration easier for you guys, I have also deployed the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever new models or extensions drop, they always follow up immediately. Additionally, Running Hub provides an online community for ComfyUI creators where you can find tons of inspiration and sample workflows. Next, let's break down this workflow for you in detail. Although there are two models, one called Turbo and one called the Standard model, these two workflows are basically identical. Let's look at the Turbo model first. We all know that a Turbo model is essentially an accelerated model, but you have to note that the Turbo model size is the same as the original model. For the text encoder and VAE, we are loading the ones from Flux 2. These make up the three core components of the model we often talk about. In the prompt section, we have the positive prompt, but for the negative prompt, you can simplify it. For example, here we just connected a 0 out node. Because we are using the turbo model, normally the CFG needs to be set to 1, and the negative prompt has no effect. So we can just handle it this way. In the sampling settings, we only use 8 sampling steps, set the CFG to 0, use Euler for the sampler, and simple for the scheduler. But many of you might notice that outside the main process, we also have a prompt enhancement process. The prompt enhancer we load here uses the load clip node, but there is a note next to it saying prompt enhancer, or PE for short. This means that the one we are loading is different from our traditional text encoders. You will also find that its subsequent node is not the text encoder node we usually talk about. This entire flow is used for prompt enhancement. I need to emphasize here that this model is a standard text model, not a vision model. Even though we can see an image input port in the text generator, if you feed it an image, it won't be able to read it. So it primarily focuses on reading the prompt you write. So how do we use it? First, we need to write a prompt manually. This prompt is mainly to describe what kind of image you want to generate. It doesn't need to be super detailed. Then, there is a prompt engineering template here. This template itself doesn't have anything special, except that besides describing the image we want to generate, we also need to specify our resolution, meaning the width and height. That is exactly why we have a bunch of replace processes here. Additionally, there is a switch node here. This is mainly to control whether or not to enable the prompt enhancer. If you select true, it means enable it. If you select false, then the prompt will just be the one you initially wrote manually. Let's use the prompt below to generate an image. This is a photorealistic image showing a beauty in the water. Therefore, the overall environment is quite complex, which will be a good test of the model's generation capabilities. Let's first look at the image generated by the turbo model. From a distance, it looks okay, but it doesn't hold up to close inspection. If you zoom in, you will notice that the overall skin texture looks extremely rough and lacks refinement. And I have tested this. This is not an issue you can fix by increasing the sampling steps from 8 to 20. Even if you increase the steps, the generated result still won't be very good. So this is an inherent limitation of the model itself. Next, let's take a look at what happens if we don't use the turbo model and use the full model. Instead, we don't need to go into detail about the overall workflow, because it is basically identical to the turbo model's workflow. The only differences are, first, you have to swap the model. Second, for the negative prompt, you can't just simply use 0 out. You at least need to put a text box there, even if you leave it completely blank. Additionally, the CFG needs to be changed from 1.0 to 4.0. Another thing is the sampling steps. You have 2 choices here. The official ComfyUI recommendation is 20 steps, but there is a note below it saying that if you want better results, they recommend 50 steps. So here, we will still set it to 50. Everything else is exactly the same as the turbo model. Now, let's use the same prompt to generate an image. Let's look at the final generated result. You will find that it looks much more natural than the turbo model. But undeniably, 50 sampling steps is indeed a bit time-consuming for us. So here comes our dilemma. The turbo model is fast, but the quality isn't high enough, while the traditional model has high quality, but is too slow. Is there a compromise? Yes, we can put them together in one workflow. This way, we can reduce the model sampling time while improving the quality of the generated image. But you have to remember, you are essentially trading space for quality and time. The conservation of energy always applies. So next, let's see how this mixed sampling workflow is done. The basic structure hasn't changed. We simply changed the traditional one-stage sampling into a 2-stage sampling process. To make the sampling process more explicit, we must swap the basic sampler for an advanced sampler. This is because we need to specify exactly when to start sampling and when to end, and standard samplers don't have these input options. In my workflow here, I perform 20 sampling steps in total. The first step uses the turbo model to sample the composition. If you pay attention, you will find that our current turbo models basically build the composition for you in the very first step. If you are worried, you can let it sample for 2 steps. 2 steps is generally more than enough. You might say you want to give it more, but that is really unnecessary. So here, we can set the start to 0 and the end to 1. You could set it to 2, but I wouldn't recommend any more than that. Similarly, for the subsequent sampling stage, We need to start from step 1 and end at step 20. Also, you need to note that even though this is a two-stage sampling, we do not recommend disabling the add noise option for the second sampling stage, because in the composition phase, we only added noise for one step, which I think is insufficient. Therefore, I advise you to keep the add noise turned on for the second stage. Let's use the same prompt and run this combined workflow one more time. You will find that this time we used less time, but the generated image quality is still very high. Through my demonstration just now, you will notice that this model is definitely not in the same tier as the Z-image and QW-Min-Image models we talked about before. The quality it generates is much higher. Furthermore, I feel it is starting to approach the level of Nano Banana 2. To prove this, I did a lot of testing. I generated over 30 images across 6 different dimensions. My final conclusion is that Ernie Image is probably the most capable open-source image generation model available right now. Now let me briefly break down my test results for you. The first dimension I tested was stylization. I need to clarify that I used prompts with very distinctive features. For example, take a look at this pencil sketch effect. Isn't the generated girl very distinctive? Also, look at this cake. Not only is it a photorealistic image, but it also mimics the feel of Van Gogh's Starry Night. Did you notice how perfectly and naturally it blends the two? Another example is showing clocks in different styles within the same image. I think this effect is also absolutely fantastic. We achieved the same great effect using characters as well. Additionally, we had the model generate a comparison image between an anime character and a photorealistic character. I feel the photorealistic character looks slightly weaker in this one, but overall, the quality is incredibly high. The second dimension I tested was text and image layout and structural output. First, we have some basic product design elements such as this fashion design card. We also have a text card of a deer featuring multiple languages. Then there is a photorealistic image of a group of people having a meeting with a whiteboard filled with complex, dense text. We also have something like a social media page design, which contains a massive amount of content. Furthermore, there is a conceptual design showing a schematic diagram of a neural network. I think this design is highly innovative. Finally, there is a coffee cup made entirely out of text. You will find that all these images are very distinctive, and they clearly prove that this model's capabilities in text generation and text and image layout are indeed remarkably strong. The third dimension I tested was photorealistic images. Honestly, I didn't have very high expectations for this test because I feel that current text-to-image models already do this incredibly well. But undeniably, Ernie Image does it even better. Take a look. The selfie-style image captures that natural casual vibe perfectly. There are also some special scene images like a girl sticking her head out of a car window the moment the wind blows against her cheeks. I think this is executed brilliantly. Another one shows the light from window blinds falling across a girl's face. I find this lighting and shadow design highly artistic. Also, I must mention this vintage photo of a boy and a girl hugging each other. It genuinely gave me that nostalgic feeling of the passage of time. The fourth dimension I tested is what I call split screen design or character design. There are many split screen design effects here, such as showcasing various hairstyles. There are also two typical storyboards, one in anime style and the other in a photorealistic style. Take a look at the overall execution. It is truly spot on. Additionally, there are 3 character designs, including a breakdown of character expressions, a breakdown of outfits, and even an analysis of accessories. Seeing these, you might remember that these are the exact same test cases we used when evaluating the generation capabilities of Nano Banana 2. The fifth dimension is what I call city cards. These are also test cases we frequently used when evaluating Nano Banana 2. It blends stylization with abstract urban representation techniques. The simplest example is when we showcased Paris. We used an origami-style Eiffel Tower. When showcasing Italy, we used a pizza box that looks like a pizza is being taken out, but the pizza itself is replaced by the Leaning Tower of Pisa or other city landmarks. Similarly, when showcasing Tokyo and Shanghai, we condensed their landmark buildings into a single macro-style image. The sixth dimension is what I call advertising creative design. This includes product poster designs, product prototypes, and conceptual designs. Although I am not a professional in product design, I feel that the generated images look incredibly premium. Through the tests above, I think it is safe to say that the Ernie image model possesses exceptionally strong capabilities in stylization, photorealistic character generation, text and image layout, character design, and product design. At the same time, I have provided 3 types of workflows for you guys: the turbo version, the standard model version, and the combined version. One focuses on speed, one focuses on quality, and the other finds a perfect compromise in between. You can choose different workflows based on your own needs. All right, I highly recommend you guys give this model a try. That is all for today. Follow me to become someone who truly understands AI.